Good afternoon, everyone. Let's start the session. If there's people joining later, the first bit is not that critical, at least. So this session of a contact analysis for Nastran based on the Apex interface. And what I'll use will be the new interface. So just to show all the new scenarios. So I'm going to use the new instead of the legacy. So the difference is it supports a lot more functionality of Nastran, but with more power comes a lot more options and button clicks and settings and so on. So it's a bit more different to set up. So what I found was most of our clients tend to want to use the newer interface. So there's a little bit more that you need to understand in terms of how Nastran thinks and acts, but it's not that much, or at least that complex to do it like this. Okay, so let's kick off. So I start with a model that's got parts and meshes, and I've got properties already assigned. So that's it. There's no loads, no boundary conditions. And what I've got is a couple of separate parts. I want to glue those together. Effectively, they'll be welded. I could have meshed them together. In this case, I want to rather show you the different contact options. Then we've got bolts that we want to apply a preload to. There's a nut that's separate from the bolt, so I need to glue that in place and I need to preload the bolts. So the first thing I want to discuss is just briefly setting up the bolts themselves. Okay, so there's bolt functionality in Nastran. For that, I go to the interactions and select the 3D bolt option. I don't want to automatically create a preload, so I want to switch that one off from the start. And I want to specify where it creates an additional node. So let me first create it, and that'll probably make a bit more sense how this works. So for this, I can specify I want to create it for all of these. And what this tool does effectively in the bolt method in Nastran does is it figures out what the orientation of the bolt is. So I can have bolts in every orientation imaginable. It doesn't really matter. So once I create it, you'll see the bolts, and then the three, you've got the bolt entities highlighted. And there's an interesting one that appeared there. These little nodes that it added, they are, if I look at this control node location, 10% outside of the bolt. So these nodes are where we'll apply the preload to the bolt and then to lock the bolt. In other words, effectively the number of turns that we have applied to the nut, we'll lock that in place. So if I just expand that, so you'll see these are those nodes. So let's just give it a more sensible name. So this is the old preload node. Okay, I'm not going to really use it, but it's just convenient to know what they're about. Okay, now to apply a preload to a bolt in Nastran, I apply load in the X direction of these nodes, independent of the orientation of the beam. Nastran already knows the orientation, so we simply need to apply load in the X direction. So they'll preload the bolt, but if I then want to apply load to the structure, I effectively have to lock in that preload. And to do that for the second subcase or load case, second step, depending on the analysis settings, we're constraining those nodes in the X direction again. So let's start by creating those, and I'll create the constraints first. So I go to constraint, and let's start with I'm going to use a very simple constraint at the back. So let's say constrain plate, and constrain, let's say, these faces. So yes, I can pick better places and location to constrain. This is simply to show how the contact works. So it doesn't matter too much. Okay, so if I just switch it off so that it does not clutter the screen too much. So that's for the constraint. But then I need to lock in the preload. So let's call it lock in preload. And for that, I only need to constrain it in the X direction. So for that, I can select all of these nodes. So I just must click. So there's the constraint. It shows it in the X direction, as expected. That's the X direction. But it applies it in the correct direction. In other words, in the stop the bolt from stretching direction. Okay, so at this point, we've got the constraints, but what I need to do for my load cases is I'll first constrain just the plate and apply a force to the bolt. And the second one, I need to still constrain it at the back, but then apply that constraint as well. So to do that, I need to create, and this is now important for the new interface, a constraint combination. So let's call the first one the preload constraint. And for that, if I look at the constraints available, I only need to pick the first one. So I constrain the plate, but I do not yet lock in those additional constraints. Okay, and then for the second one, load constraints. That I need to constrain both of them. Okay, so I'm still going to constrain it at the back, but then fully constrain it as well. Okay, now if I look at the constraints and the list there's all the constraints. And when I just double click, I can see Apex automatically assigned IDs, and this will go straight through to Nastran. If I look at the additional ones, now it's got an ID of 3 and 4, and it's a good idea to be careful with ID so that they don't overlap. By default, Apex shouldn't create overlap, but it's still worthwhile checking it because Nastran allows it and Apex also allows it. Okay, so let's switch these off then. The next one is we need to apply the loads. So the first one is let's do the preload, the bolt preload force, and I need to specify a scale factor, which I can make 1, and I want to apply, let's say, 8 kilonewton preload to this. Okay. And again, I want to select those nodes. Okay, so what's interesting is for the force, it kind of figured out at least that that's the direction of the beam. So it applies the load in that direction, which is visually sensible, but it's not in the direction of the node, which is fine because that's the intent. So this is convenient. The constraint, it still shows in the X direction there. Okay, now the next one is I want to apply a load on that face to apply it sideways so that I can see the bending. Any other loads make it kind of difficult to actually see additional stresses in this model. So for that, instead of applying a force there, I'll create a pressure, but there's a special case of pressure called the total load. So it still applies a pressure. Let's call this side load. And we specify load in the y direction of 1 kilonewton. I can specify it on that face. And that will now calculate what the pressure should be to generate a 1 kilonewton total force on that face. Okay, now I can also, similar to the constraints, apply these load combinations. For the loads in this model, I do not need it. In general, you'll typically use it. The reason I don't need it for this one is for load case 1, I'm going to preload, so only that force is active. For load case 2, I'm constraining or locking in that preload, and only this load will be active. So by not creating them separately, you'll actually see on when I create analysis how the two differs. Okay, so at this point the model is kind of okay. The only thing that's still missing is contact. Okay, so if I go to interactions again, I can specify contact, and there's contact bodies and interactions. A contact body is simply a group of elements that can make contact. There's very little requirements of what constitutes a contact body. I can make all of this a single contact body, and in theory, then let everything touch itself. The only problem is how I want to model this will be, I want to glue the bolt to this. In other words, it's physically connected as it's welded together, but then I want friction between that part and this one. So touching contact, include contact. And if I select everything, it's going to make it impossible to specify those special settings. If I go to the next one, the interaction, this is where we specify, okay, I've got my contact bodies, how do they make contact? Now the default option there is to auto-define everything. So I don't plan to use this, I just want to show what it looks like. So let's select everything and we'll create all my interactions and contact bodies and so on. So let's start with the contact bodies. You'll see there's quite a lot of contact bodies. All the different, every nut, washer, bolt is a separate contact body. If I look at the interactions, it's interestingly enough in 2 locations, and I'll mention why later on. So there's a list of interactions and there's still more interactions. So it looks like there's 51 in total. Now this is a pretty small model. As your model sizes goes up, it really quickly gets to the point where it's a massive pain to try and find the right one. So let's just briefly look at what this looks like. If I deactivate the mesh and the geometry quickly, you'll see all of these, and there I can see what the mesh is, kind of a preview that says this is where it should make contact. Okay, so this is kind of as expected. There's, between argument's sake, the nut and the bolt, the nut and the washer, and so on. Now let's say I need to change this, because by default on that auto creation tool, I set to just glue everything together. But I want this washer to be able to slide. So in other words, if my load is big enough, that bolt should slide and then probably make contact there. And I'm not going to set the contact between the bolt and the plates, but in theory, that's the correct way to have done this. So I can then, by hovering over the screen, you see these little icons. If I find the right one, I can change the behavior. So if I select that one, you will see interaction number 14 is highlighted. And if that I want to change, argument's sake, to a touching contact, and I can specify a friction coefficient, let's say 0.15, just as a number. Now, just notice as well, Apex with the auto setting, try to figure out what kind of a contact distance made sense. So I'm just going to use, that's about 0.2 millimeters. When I do it manually, I'll use that 0.2. There's a whole series on contact that we've done before, which explains all the differences and meanings for these. So if you're interested in what the correct value there should be, please look at those videos. Okay, so if I change this, notice that in the tree, it looks slightly different as well. So we start with, so just a second, just need to mute some people. Okay, so we start with, it was glued contact. I've changed it now to touching contact. So notice also the color on the screen changed. So this, not certain, almost white and a pink, that was for glued contact, and this blue and red is for the glued contact. Now it looks patchy because it's for the different elements, top and bottom side. The one is blue, the other one is in red. And I can do this, and to make it slightly simpler, I can change the name there and call this plate to plate contact arguments. Sorry, badly spelled. Okay, but this is a bit painful because I need to specify touching contact there and there and there and there. We end up with a lot of contact bodies and a lot of contact pairs. So let's restart the whole process, but in this case, we'll do it manually. I'll delete all the contact bodies as well. And let's just activate the geometry. We can activate the mesh, but let's hide the mesh just temporarily. We'll also hide the bolts, these little yellow lines. Okay, now to create the contact bodies manually, I go to the interactions again. And now I specify contact bodies manually. So let's start with these plates. We can call it whatever you want. Let's call it side plates. And I want to select these two. So notice they're completely separate, but it's okay to define them as a contact body. And the reason I define them as one is because the settings from there to that plate is the same as from there to that plate. And from there to that washers are the same as there to that washers. Okay, so if I create it and just expand this again, we'll now see, okay, it's set automatically. Let's just delete them again and do it correctly this time. So interaction, side place, I just don't want to do it automatically. So it's this part and that one. And there's now that part is created in the tree. Now I'm just going to collapse that temporarily so you can see as I create them, how it adds the contact bodies. So let's call it a middle plate. And yes, I know there will be much better names for this. For this model, let's just make it really easy to figure out what is what. Then let's call that bit at the front cylinder. Then all the bolts, I can, let's hide everything and just show the bolts. And we'll call these the bolts. Then the nuts. And then lastly, the washers. If I activate my assembly again, you can see all my parts. So that's the side plates, the middle plate, the cylinder at the end, the bolts, the nuts, and the washers. Okay, so at this point, we've got the parts that can make contact. The next step would be to define how they make contact. So we go back to interactions again, but now we specify interaction. And let's start with the touching contact because there's a lot less of them. So I'll change it to touching, and that's what I said. We'll use that 0.2 millimeters and friction coefficient of, again, let's say 0.15, which is relatively low. Now, it's a great idea to, at this point, define names that says what is touching what. So let's start with side plates to the center plate. And then the other touching is from the side plates to the washer. Side plates to center plate, middle plate, whatever you want to call it. And for this, we can pick it in the tree. So I want for the first one, side plate, and then the middle plate, second one. Okay, now if I just expand there, I'll see my interactions appear again. That one is then for that pair. If I want to see what it looks like, all right, then I can see that actually makes sense. And as shown before, the blue and the red one is for touching contact. So I'm happy with that one. We can show these again. The next one would be touching between these parts and the washer. So that's the side plate and the washer. So again, the side plates and the washers. So it appeared in the same location. So let's hide the first one just to see what it looks like. It looks pretty decent. Then all of the rest are glued. I want to glue the bolt to the washer. I want to glue the nut to the bolt and the nut to the washer. Okay, so I changed this to glued. Use that same 0.2 millimeters, but now we specify the, let's say, the bolts to the washers. So we specify the bolts and then the washers. And again, I can just hide these to see what they look like. Always a good idea to check that. So that's at the top, which makes sense. If I just collapse that, I can at least more easily pick these. So the next one is then so the bolts don't touch anything else other than the nuts. So let's say start with instead of the bolts, now the nuts. The washers, so nuts, washers. Okay, and again, this is added to the other set of interactions. So there's two of them, and it's not a case of these are glued and those are touching. It has to do with the parts, and I'll show you in a bit why they differ slightly. Okay, so the nuts are glued there. I also need to glue the nuts to the bolts. So nuts to bolts from the nuts to the bolts. Okay, let's have a look. So there makes sense. That's where the thread will be effectively. And then the last one I want to create is then that pair, so the cylinder to that middle plate. So cylinder to the center plate. Okay, and I pick these, and that should then there, as you can see, it created that one. Okay, so at this point, everything that should touch anything else is selected. Everything that it should be glued to anything else is also selected. So the last bit that we now need to do is to specify, and this is again because it's a new interface, we need to specify the contact table that says what can touch what. In this case, I'm happy to just select all my contact pairs. Some analysis, during part of the analysis, some things can either touch and change later to glue, or something touch and later cannot touch, so you may want to change it. So let's call this, and this is the first one. I'll manually assign an ID. It's not too important, but let's specify this. And I need to check that that ID and these don't overlap. Okay, now because I created those automatically and deleted them, these are now offset. If they weren't, I just pick a number there that's greater than any of these. Let's say 1001 or something convenient. Okay, now the next one I create is a bit less obvious. This is a Nastran specific thing. If you understand Nastran, it makes a bit more sense. I'll just select them and I create specifically a contact table with an ID 0. Okay, so if we step back a little bit from this, when we run a contact analysis, we start with a certain contact behavior. Does everything touch everything else or not? And there's some default behavior in terms of how it touches. If I specify a contact table with ID 0, then it means that one will be used for the initial. So by doing this, I can double check that my initial contact before the run starts, before there's any loads applied, that all of that is done correctly. So if I look at the two, they're effectively exactly the same. It's simply the ID that differs. Okay, so that contact table 0 is, I prefer to use it. It's a safer way to run and get models to start. You don't really officially need to use it. It just makes your life easier and safer to understand what exactly you're modeling. Okay, so the next step is the model is then ready to start setting up my analysis. So I'll create a scenario, and this will be a solve 400. It's full on contact. I could have added plasticity and so on. I'm not going to do that. There's only one load case. Okay, now if you're used to all the other Nastran sequences, we'll have more than one load case. So 400 works slightly differently. What we usually use load cases for is the one either follows on the next in, let's say, Sol 106, the older Nastran nonlinear format. And that sequence is important. If I look at this, if I apply that load before tightening the bolts and then tighten the bolts, I'll get a different behavior than if I first tighten the bolts and then apply that load. So the sequence is important. Now, in Solve 400, it's split into load cases and load steps. So load case is a complete analysis from start to end. So load case 1, I'll keep that, but then I say add a step, and I'll actually add 2 of them. Let's just complete the list. So the first one I'll call preload. Preload bolt, whatever you want to call it, doesn't really matter. And the second one I'll call load in Y. Okay, so in the first one, I'll set up the loads and boundary conditions for the preload. The second one, I'll specify that load and then the bolts locked in place and the constraint on the backside. Okay, now let's start from the top and just give it a better name. Scenario T sounds so last century. Okay, so let's call this bolt preload with side load. I mean, it can give better names than that. But notice this is the first time I've added underscores. You don't need it. It just makes it easier then, because this will be the name of the Nastran file that we're going to run. And command windows and so on really doesn't like spaces. Okay, so the next step is now we need to specify which model we want to run. So if I go back to this, I can run anything from the full analysis up to that assembly, which in this case, since there's not a second one, is still the same. But I can also run just parts of the analysis. In this case, I definitely want to run everything. So I specify the top level, which says everything in the model will be analyzed. Model configuration is not important. It has to do with the newer model features and so on. So the next step is we need to apply loads and boundary conditions. Now this I need to explain a little bit in terms of this is the new interface or the new interface to Nastran, and how it works is same as Nastran. The higher up something is, the more it will be used. So if I specify the constraints on this level, it will actually be used for all of these. Now in this case, I want to use different constraints for the preload and for the load. So I'll rather specify on this level. So for the preload, the constraints, I specify, well, I've conveniently called it preload constraints, and I can pick one of the others, but only one of them. Okay, so in this case, I just picked that one, which is why I created that constraint combination apply, and the loads, I can specify I want to apply the bulk preload as well. So just to make it smaller, you'll see my static load, that'll be written, and my constraints will be written to the deck as well. For the next step in Solforum terminology, I want to use a different constraint. So this is now for the load, which is actually a combination of the first two. And for the load, we'll specify that side load. Okay, so my load is then defined. Every step already knows what it needs to do. The next, and this is for this specific session important, is your contact and glue settings. And we need to specify our contact table there, but there's a couple of things we need to do before then. So this is where things get really complicated. Not because there's lots we need to do, but because there's lots that we can do if we need to change. Now, lots of these settings will be explained in that previous series, or the contact series that we had. So it explains in a bit more detail some of the things we can and want to do. In this case, we only need to change two things. The first is I don't want to run node to segment. I want to run the segment to segment contact interface. So it's effectively face to face instead of node to face. And one other thing is, even if I specified friction, default friction says there's no friction because I need to specify a friction model. So in this case, I'll just pick the first one by linear Coulomb. And that's all that I need to change. I'll just briefly go through some of the others. So there's contact detection properties. So that's my distance tolerances and bias values and so on. And again, we've explained that in that previous contact settings. The defaults for this model is more than good enough. Okay, so that's the global settings. And then for the load cases, all that I need to add is my contact table. So I select that contact table. Notice number 0 isn't available to be selected. And I want to use the same contact table for the second one. So I select and pick that one. Now this is again why we need to specify different IDs for the contact pairs and for the table. Because again, if it overlaps, then we're kind of mixing them together. So by doing this, ID1 only refers to the contact table, and that table effectively already contains all of these. The next one, that if you're on a contact analysis, I strongly suggest you do, if you go to the output request, by default, it doesn't ask for contact results. So that's one of the most useful results to check and debug contact models, contact results. So if I activate that, remember to activate plot as well. Plot is your normal result file, the one that you read into Apex or Pattern or whatever, and print is your FO6 file. So if you don't specify that, just this one, it'll write it to the null result file and to the print file, the FO6 file. And that file then becomes a pain to read. Okay, so that's the only change I need to make there. Then the last bit that we need to do is we need to specify how the loads will be stepped over time. So we go to simulation settings. The most important bits we want to do here is I need to specify some kind of a stepping. So in other words, this is important for nonlinear. If you apply a full load in one step, it may be so nonlinear it can't converge. So we may want to use smaller steps. Usually contacted for preloads at least tend to be pretty close to not linear, but at least easy to converge. So I've created that one. Let's just give it a better name. Preload stepping. And we can specify some predefined stuff that says my model is quasi-linear, or it's mildly nonlinear, or severely nonlinear. Based on these, lots of different settings will change. I can also manually change all of this. In this case, I'm happy with this. Quasi-linear means it'll try and apply that load in one step, and it tweaks some of the additional settings that goes together with this. So I apply that. Notice that that's now applied there as my preload stepping. For the next one, for the load in Y, I can use different settings. Now, for most analysis, your preload is one of the easier steps to create. So let's just create a new one. We'll call that full load or applied load. And I'm going to use, in this case, again, quasi-linear, just to get the model to run faster. But this is a pretty simple model. For real models, we'll probably pick mildly or severely something that's a bit more complex in terms of nonlinearities. And this is only nonlinear in terms of friction, and contact will be pretty much at those locations where I expect very little, if any, movement. Okay, so we've now created the two. And just one interesting one. This was added relatively recently, so there's improved settings in terms of runtime. So there's a couple of changes it makes in terms of how it solves. It tends to use less iterations, and iteration goes faster. Which one you pick doesn't matter in terms of accuracy or results. This one just runs faster. Now, for this model, the difference was 2 minutes versus 1 minute for the runtime. So if I've done everything correctly and I didn't miss any steps, let's just save the model, and I'll right click there and run the simulation. So let's see if there's any problems. Hopefully not. Once it starts running, I'll bring over the settings to show you what it looks like. So there's the FO6 file, and as it's running now, it shows you some basic info. I just want to step slightly back just to understand what this file says. We're now busy with the nonlinear stepping. It's trying to read it's trying to reach 100% of the full load for load case number 1. But with the first increment and this first iteration, and there in displacement, load, and work, that's where the convergence tolerances will be for that step. Then for the second step, it now converged, now it does the same. Now, if things go wrong and the model doesn't converge, this is one of the useful results. It says the displacement, average displacement for all of the nodes in the model is about 0.04. My model is running in millimeters, so that's 40 microns. The maximum displacement for this one is just over a millimeter. If I go back to the previous section, so for load case 1, that was about 20 microns, which kind of makes sense for the preload. In this case, I'm loading it sideways, so that thing will bend a bit. Now, the advantage of that is in a previous model that I ran, I forgot something small, and that didn't converge, but that number immediately jumped to hundreds of millimeters. And then it says, but that maximum is at this node and this direction. So I can then look at that node and direction to see why it actually moved so much. So at this point, the model has completed running. Even in Apex automatically figured out that it's available. So let's have a look at the results quickly. In terms of the results, we'll now see that static ID 0. So that's at the beginning before the run actually starts. So if I activate the contact status, one of the most useful features, a value there of 1 says it's in contact. If it's this gray, it's not in contact. So there you can double check what makes contact and where and how. So if I change this to wireframe, I can at least see where it's making contact, or I can switch on and off different parts to see. But this pretty much looks like what I expect to see. It's also very similar to what that contact showed in Apex beforehand. So then if I double click on that one, all of my steps, so we just explain, you'll see there's actually 2 steps, the preload and the load in the y direction. And for this, I can now plot much more. So things like stresses and displacements and so on. Now, this bar at the bottom, the first one is still that it's time 0, or the before the run starts. This one is for the next step. We apply the preload, and that will be at the end. So let's activate the stresses. So this is for mesostress. And as expected, at the beginning, there's 0 stress because this is before the run starts. Okay, now we go to the first step, the preload, and now we see some kind of a stress. So for mesos of about 150 MPa, and then on the bolt on the nut, I can also, if I expand this a bit, we can see what is what. We can switch off the loads and constraints. And if you only want to see the bolts, do that, and I can see what the bolts and nuts and washers look like. Okay, then if I go to the next step, there it says that's at factor 2, or time 2 in other words. It's the final load of the second load step. And we see the stresses has increased a bit. Also higher stress on that side. We see there's some kind of a stress top and bottom for this, but because it's from mesos, it's the same. So if I change this to, argument's sake, let's say that's the Z direction of stress, so the Z component, I now see the tensile and compressive. So it's tensile at the bottom and compressive at the top stresses. I want to plot the deformed shape. So there's movement. It was similar to, we used the pattern. We've got through scaling and relative scaling. I'm going to scale this up, let's say, about 10 times. And as expected, bends like this. Now, one of the things that you'll notice is when we run a linear analysis in Apex, it defaults to relative scaling. For nonlinear analysis, it's true scaling, especially related to contact. Now, this is a very special case where it's kind of okay to scale this up. And the reason I say that is, let's say I had a part that started a little bit away from this. Now it moves in, touches, and then it bends. If I scale everything, it will include the scaling for that initial motion as well. So it'll look really strange if I use a value other than just the actual displacement that you see, because you'll see parts in contact, but the part in contact is hanging somewhere in space. This is only because we artificially scale it. But okay, for this model, since everything starts in contact, and apart from there, where it opens up a bit, stays in contact, it kind of makes sense to actually have a larger value, 20 or 30 or something. So there you can nicely see how it opens up there. I can also plot the contact status, and now you can see it's not making contact there anymore because it's, well, opening up as expected. Okay, so that brings us to the end of this session. I did not spend a lot of time and effort on any of the more complex and more detailed types of contact and settings that we can get. If I tried to go too deep, that the session would have run over multiple days probably. So we'll probably leave that for a later session then to go into detail on some of the settings that's available in contact. Okay, so thanks for attending, and let me know if there's any questions.
Is there a way for you to do that contact analysis outside of, obviously you've shown us kind of the visual way. Is there anything outside of that visual way without using, because I mean, I'm sure if you hadn't used that scaling factor, we weren't going to be able to see that separation.
Okay, so let's do that quickly. If I scale this back to 1, see the contact status doesn't change, and this is why I prefer getting that result. So if I now expand this again, let's say we want to see, so everything we start with the brackets. See, this is where it touches. You can see it only makes contact there and there, close to the washer, and then it makes contact in a sub-region there. Let me just change the settings so it doesn't keep on. So in this case, there's a contact patch over there. Everything in gray is not making contact anymore. And there at the back, based on the
Okay,
light.
that helps.
Yes. So I can do the same for the sleeve and use the other one.
So basically, if you showed it in that bolt preloading step, then it was going to have kind of a blue area there where
Yes.
those plates are contacting that center
Okay,
plate.
I'll go to that step in a moment. Just want to hide this center plate. Sleeve, let the bracket, yeah. There you can just see on the other side. Okay, let's just show only this one. No, sorry, wrong one. Only the bracket. If I go to the previous step, it's now only making contact there. So as it preloads, it bends the plate and so on, so that it actually opens up a little bit further away from this.
Okay.
There's additional things we can plot like contact stresses. So there you can see where the stresses are due to the contact as well.
All right, that helps. Thank you.
Is there anything else? Okay, if there's no further question, then this concludes it for the session. Thank you for attending.